Good evening, friends. Now I want to explain about in chemical bonding atomic radius. I will explain about atomic radius. What is atomic radius? If we take, for example, take this electron, the distance between the from nucleus. This is nucleus. The distance between the from the nucleus to outermost electron. The distance between the nucleus to outermost electron is called atomic radius. This is called atomic radius, but the electron is not in a fixed position. It is a wave function. Like this. It is not a fixed. We cannot define its boundary. Electron is a wave nature. It is not having fixed position. Fixed position. That's why we cannot define boundary. That's why we cannot define its boundary. In case of atomic state, we cannot measure the atomic radius in free state of electron, because generally the distance between the nucleus to outermost electron is called as a atomic radius. But in atomic state, we cannot define the atomic radius. It is difficult. Why? Because atom is a wave function. Electron is a wave function. It is not fixed in a particular position. That's why we cannot define its boundary exactly. In this case, that's why it is cannot identify an atomic radius in a free state. How can we measure the atomic radius? This is measured in a bonded state. This point is very important. This can measured in bonded state. The atomic radius of an atom we can measure in bonded state. For example, AA means this is a covalent bond. Based on that, the radius of the atoms we can define different types. For example, to take bonded state, or in attraction state, we can define atomic radius as different types. For example, first one is covalent radius, second one is van der Waals radius. Van der Waals radius. This is second one. Third one is metallic radius. Fourth one is ionic radius. These are the four types of radius existing in the atoms in bonded state or attraction state. First one is covalent radius. If it is van der Waals radius. Third one is metallic radius. Fourth one is ionic radius. Next we discussed one by one. One by one. First we discussed covalent radius. What is covalent radius? First we discussed about the covalent radius. covalent radius. Covalent radius. Covalent radius. How it will form covalent radius? How it form? How it will how can it form the covalent bond? By sharing of the electron. Atom A, if you take atom A, this is atom A, by sharing of another atom, similar atom A, they will form the covalent bond. That's why this is called as a covalent radius. The radius of this A molecule is equal to the distance of AA by 2. From the nucleus of center of the nucleus of the A atom to from the center atom of the another atom of the A nucleus molecule is called the distance. Half of this distance is called as a radius of A atom. AA distance. This is called as a covalent radius. If you take different atoms, for example, if you take A and B, the electronegativity difference between the electronegativity difference of A and A atom is same. If in case AB, if you take this is the A atom, if you take this is the B atom, the radius of AB is equal to the distance of AB by 2. In case of electronegativity of A is equal to electronegativity of B, then only this radius is existed, covalent radius. By formation of covalent bond, then only it is covalent radius. If it is electronegativity of A is not is equal to electronegativity of B, what will happen? This is the more electronegative atom A is greater than electronegativity of B. This is B atom, that's why this is more electron attract towards A side. Then what is the formula of the radius of the AB is equal to radius of A plus radius of B minus 0.9 of xi A minus xi B. Xi A minus xi B is electronegativities of A and B. This is the formula of the radius of A and B. In case of more electronegative, two different electronegative atoms combine form the covalent bond. This is the formula of the, in case of, for example, take HCl, H plus plus Cl minus. This is A, if you take this is B, whatever it may be, A or B, then we can, two different electronegative atoms also you can find out. In this case, for example, hydrogen is the molecule, then it is AA, radius of AA is equal to distance of AA by 2. By formation of covalent bond, we can define the covalent radius. This is about the covalent radius. Next we take another molecule, that is another next one. Next topic we discuss van der Waals radius. Second one, van der Waals radius. Van der Waals radius. What is means by van der Waals radius? What is mean by van der Waals radius? Van der Waals radius means the distance between, if you take, for example, the distance, this is van der Waals attraction. What is intermolecular attraction? It cannot form the bond, just the intermolecular attractions is called van der Waals force. What is van der Waals force? The intermolecular attractions. For example, if you take A molecule, if you take B, there is no bond between them, just the intermolecular force of attraction between A and B is called as a van der Waals radius. If you take radius of AB is equal to the distance of AB by 2. This is the intermolecular force of attraction is called as a van der Waals radius, van der Waals force. Then the distance between these two different atoms is considered as a and B by 2, half of the distance. Just there is intermolecular force of attractions. If you take, for example, A and B, If you take another molecule A and B, if you take another molecule B and A, the distance between these two is called as a radius of A, radius of BB is equal to distance of BB by 2. If in case of, in this case A, if you take distance of A is equal to radius of A is equal to distance of A by 2. Just there is no forces of attraction, there is no bonding between the A molecule and B molecule, just there is a intermolecular forces of attraction between them, then this is called as a, if you can find out them their radius, then this is called as a van der Waals radius. What will happen? Covalent radius is, what is the in this case covalent radius means the by sharing of electron between the two atoms, we can consider as half of them is considered as a covalent radius. But here just the intermolecular forces of attractions, that is called van der Waals force. The distance between them is called as a van der Waals radius. Generally covalent radius is greater than van der Waals radius. This point you have to remember. Covalent radius is greater than van der Waals radius. This point you have to remember. Next radius. Next one is metallic. Third one is metallic radius. What is metallic radius? How it form? Metallic bond. If you take any metallic bond, how it will form metallic bond? The free flow of electrons between the atoms, between the metallic atoms, is called metallic bond. This electron is not fixed to this nucleus. This electron is shared by another. If you take this electron shared with another 3 or total surrounding atoms, this electron is not fixed to this. The free flow of electrons will form the metallic bond. The radius between these two is called as a metallic radius. The distance between the two atoms is called as a metallic radius. This is called as a metallic radius. This is about the metallic radius. The distance between the two internuclear atoms by free flow of, how it will form the metallic bond? The free flow of electrons between the atoms is called as form the metallic bond. The distance between the two, if you take any two atoms, half of their distance is called as a metallic radius. Then compare these three radiuses, then you can find the relation between them. First one is, this is the A and B. A and B. This is the first one. This is the second one. This is the third one. This is covalent radius. This is van der Waals radius. This is metallic radius. Which radius will be greater? First, second, that is van der Waals radius is greater than. Next, after that, metallic radius is greater than. Next, covalent radius. This is the relation between the covalent radius and van der Waals radius, means metallic radius, because here sharing of the electrons. This is intermolecular force of attraction between. There is no bond formation between them. This is the free flow of electrons between the atoms. Then it will form one atom is touched with another. Then only it will flow of electrons will be possible. Conduction of electricity. Conduction of electrons. This is between the covalent radius and van der Waals radius and metallic radius. The relation, which one is higher? That is van der Waals radius is more compared to metallic radius compared to covalent radius. This is the sequence of the equation. Next, we discuss about the what in the periods and groups, how it will trend. Then we discuss about the trend, how it will varies from in the groups and periods. If you take in general concept in periods, what will happen? If you take in case of general concept, the period from left to right, what will happen? The Z means, that is number of protons increases in the nucleus. The nuclear charge will be increases. The left to right atomic radius decreases. This is the concept in the period. So in case of groups, what will happen? Top to bottom, what will happen? Number of shells increases. Automatically atomic radius increases. This is the general concept in the case of period and groups. But there are some exceptions between them. If you take in the case of period 1, hydrogen and helium. The noble gases, this is noble gases will show van der Waals exhibit only van der Waals radius, cannot show covalent bond, cannot form the covalent bond, only it will show the van der Waals force of attraction between the molecule. There is no covalent bond formation. That's why generally in the nuclear charge left to right increases, but the atomic size will be decreases. But due to the noble gas exception, then it show only van der Waals rates. That's why the helium is greater than hydrogen in case of this one, period 1. If you take another period 2, lithium, boron, carbon, nitrogen, oxygen, fluorine, neon. But what will happen in this case also? Greater than, decreases. But due to this noble gas configuration, it will show the van der Waals radius. That's why this is neon is greater than compared to remaining all the elements. Generally decreases, but this is the exception. Next, in case of period 3, what? Sodium, aluminum, silicon, phosphorus is greater than, sulfur is greater than, chlorine is greater than argon, as per the expectation. but this is due to the van der Waals radius. This is argon is greater than compared to remaining all elements. Due to the noble gas configuration, they will show only van der Waals radius. These are the some of the exceptions in the period. If you take in case of d block elements, can in general the the groups will be show same, but in case of periods, due to the noble gas configuration, they will show only van der Waals radius, all noble gases. Some of the exceptions. But in case of d block elements, if you take in case of d block elements, if you take d block elements, if you take d block elements, then you have to identify the atomic radius. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. From here to here, same trend, but here no change, but here again decreases. What will happen generally from the left to right, atomic radius decreases due to nuclear charge increases. This is the concept, general concept. As per this is same, this is as per the concept, but this is not true. Why? Because I will explain. Scandium, this is D1, this is D2, this is D3, this is D4, this is, you can also D5, D5, D6, D7, D8, D10, D10. In this case, what will happen to these three? One, two, three, up to these three. Next, here in this case, one, two, three, 4, 5, 6. Here 6 or 7. In this case, what will happen? Here from scandium, titanium, vanadium up to this, the nuclear same trend, nuclear charge increases, atomic radius increases or decreases, atomic radius decreases. See here. Here one more concept also comes. Why? Because in D there is a electronic repulsions will show. If here also we consider electronic repulsions. Here also we consider electronic repulsions. Here also. Here electronic only 3 up to D1, D2, D3. This is half field. Just 3 electrons are there. The electronic repulsions will be less. That's why the nuclear charge will dominate electronic repulsions in this case. That's why the scandium is greater than, titanium is greater than vanadium. But in this case, nuclear charge is approximately equal to somewhat greater compared to electronic repulsion. In this case, equal to the electronic repulsions. That's why their atomic radius somewhat similar, equal. In this case 4. But here due to electronic repulsions dominate the nuclear charge, because in the same orbital 2 electrons. That's why this electron, due to this electronic repulsions, the size will automatically bigger. This is the concept. Due to electronic repulsions, the size will be electronic repulsions will dominate compared to nuclear charge. According to nuclear charge, size will be decreased, but due to electronic repulsions, size will be automatically increases. Then this is some of the exceptions. What is the actual series of this atomic size of d block elements? What is scandium is greater than Scuti, titanium, then zinc will come here up to vanadium. Next, again same, chromium is greater than, next to manganese is greater than, iron is वैसा है, iron is greater than. Next will copper will come, similarly equal greater than zinc. Chromium, manganese, iron will be similar. Next to copper, next to cobalt, next to nickel. Cobalt and nickel. Zinc will come to here, copper will come to here after the iron. This is the actual series of the atomic radius of d block elements. Why? Because according to the series, scandium is greater than, titanium is greater than, vanadium, chromium, due to the similar size. After that, this is the series. But due to the electron repulsions, some of the exceptions will be shown. Here electron repulsions will be less, here somewhat greater, here dominated. In this case, nuclear charge will dominate. Here nuclear charge is equal to the electron repulsions, but here electron repulsions will be dominated the nuclear charge. That's why the size will be somewhat different. This series, scandium, titanium, then zinc, vanadium, chromium, manganese, iron is similar. Next after that copper, cobalt and nickel. Scuti में जिंक ऐसे कोई नहीं है. This is the one of the to remember easily. Scuti में जिंक वैसे या बराबर कोई नहीं. Just you remember, this is one of the common code. This is the atomic radius of the d block elements. Next we'll discuss about the before scandium, yttrium, lanthanum. Scandium, yttrium, lanthanum. Next titanium, zirconium, hafnium. Vanadium, scandium, titanium, zirconium, vanadium, nobelium, tantalum. What will happen in this case? Down the group, what will happen? Number of shells increases. Atomic radius automatically increases. In this case, scandium is greater than, yttrium is less than lanthanum, but titanium is greater than, zirconium is approximately equal to the hafnium. Vanadium is greater than nobelium, approximately equal to the tantalum. This is the series. Scandium 21. What is the atomic radius of? This is the 3D series. This is the 4D series. This is the 5D series. Scandium 21. This is 22. This is 23. Lanthanum is 57. I think 57. Hafnium is 75. 58 to 74. 58 is lanthanum 57. This is 72. Lanthanum 58 to 71. This is called as a lanthanides. After the lanthanum is called as a lanthanides. From here to here. This is 58 to 71. This is called lanthanides. Scandium, yttrium, lanthanum, titanium, zirconium, hafnium, vanadium, nobelium, tantalum. From lanthanum is 57, hafnium is 72. In between these two, 58 to 71, this is called 14 elements. This is called as a Lanthanides. Lanthanides. This you remember. This is from left to right. From the down the group, the number of shells increases automatically. The atomic radius will be increases. This is the follow the series. But as per this is also it will show the similar trend. Titanium, zirconia, hafnium. If it shows the greater, but it is equal to the equal. These two are equal. Why? Because due to lanthanide contraction from 58 to 71, due to lanthanide contraction. What is meant by lanthanide contraction? Due to lanthanide contraction, this is the number of number of electrons will be increases, nuclear charge will be increases, the number of shell be increases, but due to this lanthanide contraction it will equal, comparably similar. The what number of shell will increase compensated by the lanthanide contraction, means the number of nuclear charge. This is called as a, due to this only the zirconium is equal to size of the hafnium, nobelium also equal to the tantalum. After the this only it will come here 72, next 73. What is meant by lanthanide contraction? This we will discuss. Next I will discuss what is lanthanide contraction. If you take screening effect, lanthanide contraction, s, p, d, f orbital. If you take for example, this is the center, this is the electron, this is the electrons and electrons and electrons. This is also electron. This is also electron. This is nucleus. This is the inner electron. This is the inner electrons. This is the outer electron. This, remember, see here, this is very important concept. This inner electron will shield the outer electron. Due to this electrons is surrounded by the nucleus, this nucleus. The impact of this nucleus on the outer electron will be shielded, means very less, due to shielding. Shielded, surrounded by these electrons, the impact of the nucleus on the outer electron will be very less. This is called as a shielding effect. That's why this is called as a, if you consider as a shielding effect. In case of s orbital is spherically shaped, p orbital is dumbbell, this is double dumbbell, this is complex structure, very less. Due to this s orbital, shielding effect is more compared to p and compared to f. F orbital is poor shielding compared to remaining all these. F orbital is like this. Due to poor shielding effect of the f orbital, the effect of the nucleus from the outermost electrons are present in the f orbital is very less. This is about the shielding effect. S orbital greater than F, p orbital is greater than, d orbital than. What will happen in this case? Due to poor shielding effect of the f orbital, the f orbital what is screening effect? What is lanthanide contraction? The electron present in f orbital will be more attracted towards nucleus, the electron present in f orbital will be more attracted towards nucleus. So outer electron, that's why the the atomic radius will decreases. This is called as a lanthanide. The atomic towards the nucleus, that's why the atomic radius will be decreases. This due to the poor shielding. F orbital will be poor shielding effect. This is the screening effect. Screening, this is shielding and screening. Screening is very less. Shielding is this one, surrounding atoms. S orbital is more shielded, p orbital is somewhat less. This is about the shielding effect. But due to screening means the f orbital screening capacity will be less. The electron present in the f orbital will be more attracted towards the nucleus. That's why this is atomic radius automatically decreases. That's why this is called as a lanthanide contraction. After the lanthanum, it will enter to the f orbital. Scandium, yttrium and lanthanum. Lanthanum is 57. After that, it will start with from 58 onwards, it will start the lanthanides. That's why this is after the lanthanides. This is called as a lanthanide contraction. That's why this is equal to that one. This is about the lanthanide contraction. Next will be ionic radius. Next is discuss with the ionic radius. If you take any metal, by removing one electron, it will form metal plus. If you take any metal, by addition of electron, will form M minus. What will it form? If you take, for example, nucleus, this is the electrons. If you remove this electron, what will size will be decreases, because the attraction between the electrons is more due to positive charge. By adding one electron, what will happen? The size will be bigger. Addition of one electron will be, the size will be somewhat bigger size automatically increases. This is the ionic radius, the distance between from this nucleus to up to the outermost electron. Ion, in case of ion, then it is called ionic radius. In case of it is not ion, then we can measure the this is called the, if generally M minus is greater than M is greater than M plus. This is the comparison between the metal plus and metal minus and metal increasing or decreasing series. This is, if you take for example H plus, H minus, H, which is greater than, H minus is greater than H, next H plus. This is the series of the atomic ionic radius of the atoms. In case of isoelectronic atoms, for example, if you take in case of isoelectronic species, how it is? In case of isoelectric, for example, if you take, O2 minus, N3 minus, F minus, Na plus, Mg plus 2. Oxygen is 6 means 8. Nitrogen, oxygen atomic number is 8. This is 10. Nitrogen 10. Overall F minus is 10. 10. 10. In case the size of the in case of isoelectronic species, size is ionic radius inversely proportional to the size of the ionic radius is inversely proportional to the ionic radius is inversely proportional to the Z. Ionic radius is inversely proportional to the ionic radius size. Ionic radius size is inversely proportional to the Z. Means inversely proportional to Z. Smaller ionic radius is inversely proportional to the Z. Z means in this case Z is 8. which one is size smaller? N3 minus is greater than, next O2 minus is greater than, F minus is greater than, Na plus is greater than Mg plus 2. This is the sequence of the in case of size. This is about the atomic radius. Next we discuss about. Now close the year up.